Hey everybody, Lars here. I'm back. It's Saturday night, and I had to go down to my sister's tonight, but I'm back home. It's 1 o'clock, 1:30 at night. But I am doing review video number 2 for you because you need loops. You need loops in order to do interesting problems, and you will get them, and you will get them tonight. I always like this part. This is where the rubber hits the road, and you are going to learn how to do something interesting. And once you have loops under your belt, then you can start solving real problems and start doing real things. So this is a long one. Hopefully it won't be that long one. I'm going to try to buzz through it, but I don't want to buzz through it so fast that you don't get anything out of it. I want you to show you things and get these things across. So hopefully we walk that line. I already set up a file for us. I just put in my comments, put in loops, whatever. The first thing I want to do is maybe the simplest thing we can do. I'm just going to say my list equals 2, 3, 7, and so we start right away. We start using what we've learned before, lists, and we're going to do our first simple loop. And the reason I do this first is because I want to get across to you that we do iteration or looping in Python differently than we do in other languages, Java, Pascal. I'm dating myself with that one. C++. Usually when you do a loop in those languages, you'll set up a construct where I want to start with this number and I want you to keep going until you hit this number. And then you'll tell it to increment by 1, increment by 2, decrement, blah, blah, blah. We don't really do that in Python. In Python, you have a list. And basically, iteration is just consider everything in this list. So moving forward, you can still do 1 through 10. All you're going to do is learn how to create a list of 1 through 10. So we're going to get to that. Right now, the easiest thing in the world is to just iterate over a list and do something with it. So I say for to say I'm starting a for loop, and I, which is just a variable name. Some people think it means index. Some people think it means iteration. It definitely comes from mathematics. But when we do loops and we do iteration, we start with I. And then if we need another variable, we use J, and then we use K. So you'll see later in the video we're going to use J, but right now I just use I. So I say for I in, and then I say my list. And if I spell it correctly, I'll be in Fat City. Then I do a colon. Somebody asked before what the colon is for. The colon says I want to start a block. So you can see how idle indents for, and then lets me do something. So in this instance, real simple, I'm just going to print I. Easiest thing in the world. I run the program, and as you can see over here, oh, I was playing around. I shouldn't. Let me do this, get that hullabaloo off the screen, then I will run this again, and you'll see down here. That's good. You go to see your 2 through 4 and all of that, okay? But I don't, and I know I do this in the slides a lot, I don't want you to think looping is just listing things. It's not. It's so you can consider every variable and do something. So let's say we wanted to square our numbers. So we could have our number and then the square next to it. Another thing I think I neglect to do all the time is to let you know that you can create blocks. See? And then just when I'm done here, I'll say print the end to tell you I'm done with everything I do. So anything indented for here is going to run every time through the loop. So now when I run it, you can see when I ran it for 2, it did 2, then 4, then the cube. Then it dropped out of the loop, went up to the top, grabbed the next item in the list, 4, and did 4, 16, 64. Then it dropped out, did the next item, 6, 6, 36, 216. See? It does the whole block for every item in the list until it does 10, 10, 100, 1000. Then it drops out because the list is over. It knows what the end of the list is, and it drops out, and it prints the end right there. Okay? So that's really the simplest thing we can do with iteration with Python. We're iterating over a list. All right? Now, as always, I am going to put this up in resources for you to have and for you to play with. But for now, we are going to zotz that out because we need to move on to the second thing we need to tool around with, and that is to play around with range. If I want to do a loop for I in, let's say, from 1 to 10, I just do range 10, print I. It's actually a bird bashing up against my screen window back there. No, you can't come in. There's no food in here. All right. When I print this, it's like a Stephen King novel living in this house. There's always, listen to this. There's always insanity and there's always animals tooling around trying to get in. 3 days ago, I had some kind of sick deer in the backyard making these awful noises like, it's like living in a horror movie. All right. For I in range 10, print I. All right. Let's do this. Let's see what we get. Boom. 0 through 9. Remember, computer scientists, we're starting at 0. Okay. You see that range 10? That's shorthand. What it really is this. This is the default. Always start at 0. If you don't tell it where to start, it'll start at 0. And if you don't tell it what to increment, it'll increment 1. So basically, this command is the exact same thing as this command. Okay? See? So if I wanted to say, I don't want to start at 0, I want to start at 1. And this, as we know, is the first thing we don't want. So let's say I wanted 1 to 10. Well, I could do it that way, 1 to 10. Okay? Now, if I wanted to, I could do this. Let's see. I could go 1 to 100, and I could increment by 5. Voila. And then that will be my list. And as you know, if you read the slides, it's not necessarily a list. Range is a generator, which generates different numbers. That guy's not going to be happy until he gets in this house. The last thing, which is pretty interesting if you ask me, is we can go, I go to 0. We can go backwards. I can tell it to start at 100, go to 0, and decrement by -5. So when I run this, you can see I start at 100, and I go all the way down to 5. So that's pretty neat too. So range is just a way for us to create lists that we can iterate over. So the classic way to iterate, if you learned with Java or you learned with some other language, is to, can you believe this? They're fighting. Go on, get out. Other languages, you basically set up a construct so that you're going to do one number after another until you get to a certain condition. Python doesn't do it that way, but they want to make sure you can still do iteration a certain amount. It's called a definite loop. I want to do this 20 times. 1, 2, 3, 4, 5, 6. I want to do this 100 times. Boom, 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 boom. You can still do that. And the way you do it is by using range. Okay? So we have to go over range if we're going to do iteration in Python. It's a no-brainer. But it's not that hard. If you play around with some of the possibilities, you'll learn that it's pretty easy to go down the line and do things. So, all right. We now, for the most part here, have iteration. So let's do something interesting. I am going to say for the squares of the natural numbers from 1 to 300, which squares are over, let's say, 50,000. Okay? How would I answer that problem? We're now at that point. We're now at the point where we're going to use our Python skills and our programming skills to actually answer questions. So let's say somebody posed this question to us. The squares of the natural numbers from 1 to 300. Let's tackle that first, all right? I'm going to set up a loop. I'm going to say for I in range. I'm going to start with 1 because I don't want 0. And I'm going to go to 301 because 301 is the first thing I don't want. And I am going to, I'll just print them at first. I'll print I squared. Okay, so what's this going to do? This is going to print all of the squares. And it's going to be a lot of numbers because we have to tackle 300 of them. Okay, there you go. There are all the squares, and if we go all the way up to the beginning of the list, you'll see that 1, 4, 9, 16, 25, 36, 49, these are indeed the squares going all the way down to the bottom of the list. So this is kind of an unwieldy format, though. I'm just printing them out. I'm generating them and printing them out. I don't really need them. What if I want to save them in a list? Let's go get a blank list. And the way we do that, I don't know if I showed you that with lists, is squares equals bracket, bracket. Now I have a blank list. So instead of printing them, I can save them. I can say squares. Remember our list video, append, you're going to use it a lot. Append I2. So now, instead of printing them that way, I'm just going to print my list when I jump out of this loop, and I'm done. There's our friend again. I don't know what he thinks is in here. And as you can see, now I have a list. Okay? You see 990,000 right there. You see 14999 up here. So I have a list probably with 300. Actually, let's go find out. Print len squares. Len works with lists as well as, and as you can see, 300. So that's exactly what we have. That's the length of that. I'm actually glad I'm recording because nobody would believe this if I wasn't sitting here doing a video while this is going on. I literally have birds fighting outside of my window. What are they doing? He's perfectly healthy. He's got wings. Is he confused? Does he think it's daytime? Look. Absolutely. Well, I thought this was going to be a short video. Apparently it won't be now, because this is turned into a Hitchcock movie. It's no longer a YouTube Python video. It's a Hitchcock movie. Where's Tippi Hedren when you need her? All right, let's get this done. Let's forget about the birds. So I'm going to get rid of this print length, and I'm going to get rid of print squares. And now I have a list called squares, and it's got all of the squares from 1 to 30 in it. So let's move on to the second part of the problem. And if I look at the second part of the problem, which squares are over 50,000? So now I can say for I, because that I is done, that loop is done. And now I don't have to worry about range anymore. I could just say for I in squares. And I can say if I is greater than 50,000, print, and you know we're not just going to leave it with print I, but now I can print I. So boom, I do that, and I come up here, and I see that the first one is 5176, so I think I'm pretty good there. That actually works. So I now, for the squares of the natural numbers, which squares are over 50,000? Well, I kind of answered it because I printed them all out, and they're all out there on the screen. But let's say I wanted to know how many of them there were, okay? What if I wanted to count them as I was finding them and printing them out? If I wanted to do something along those lines, I would create something called a counter or a clicker. And what I'm going to do at first is I'm just going to call it count. I'm going to call it 0. And I'll tell you why I'm doing that in a second. Then what I'm going to do is I'm going to come up here, and with my 4 indent, I'm going to say count equals count plus 1. Okay? So every time I go into the loop, that variable will increase by 1. So it'll act like a clicker. It'll act like a counter. Actually, what I'm going to do with my print is I'm going to denote that by printing it out right next to the number. So it'll actually now tell me how many of them there are. Let's run it again. And of course there's an error. C is not defined because I've gotten ahead of myself. I don't want C, I want count. All right, there's 77 of them because every time we printed one now, we put the number next to it. Okay? Now, what's something else we can do? We can, as we go through the loop, accumulate them as well. So let's set up a variable. I'll call it accum. I'll make it equal to 0. Now the reason I'm making them equal to 0 is because, as you know from variables, we evaluate equations from right to left. If I say count plus 1 and there's no such thing as a count variable, Python will blow up. So I have to create a count variable before I go and do it. You're not looking at this sign. You're not assigning things on the fly. Like you say, you're probably thinking, well, what's the difference? I assign here and I assign here. Well, I've got an equation here that's being evaluated first. And if that's being evaluated and that variable doesn't exist, Python will let you know. It'll break. So classically what we do is we don't necessarily define our variables, but we do set them up before we go into here for counters and accumulators. Now with the accumulator, I don't say plus 1 because I don't want to click it. It's not a counter. Okay? What do I want to do if I want to accumulate something or add things together? Well, I add the actual thing itself, which in this case is I. Okay? And then, because we're smart, we'll print it here and we'll get a running total of the numbers as they're all added up together. Okay? Let's see what this looks like. All right. So now, as you can see, that right there is the first one. It's just itself. The second one adds it up, boom, 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 down the line. So now what have we learned? We've learned that there are 77 squares in the first 300 numbers that are greater than 50,000. Okay? When you add them all up, this is what you get. You get 5,323,626. Okay? So now, as kooky as this seems, because it's a contrived little math program, but think about what we just did. I mean, if somebody asked you this question 2-3 weeks ago, what would you have done? Right? But now we have programming. We have this logic that we can build these constructs and answer these questions for us. Okay? I mean, really, what would you do? You'd have to go get a calculator, square all of those numbers, and then note the ones that are over 50,000. Okay? You'd probably use a heuristic and try maybe 200 first, square it, and see where you were, and say, oh, that's not 50,000. And you'd go up and figure out where it was. But then what if you wanted to add them all up? Right? So we got loops now. This is where we can start discovering how to solve problems and using the logic in our heads and actually codifying it and putting it down on paper and doing things with it, okay? So this is the way we're going to do things and start solving problems. We're going to put things in lists. We're going to examine lists. We can look at the list to see if things are greater than, less than, see if they have certain qualities. It's going to be interesting. So there's still 3 things we need to do, which are kind of specialty items, but I want you to be aware of them. So let's go back here. Boom, boom, boom. And the next thing I'm going to do is I'm going to show you a nested loop. All right? So I'm going to say for I in range, and this is going to be real simple, 3. I am going to print outer, and then I, and then I'm going to say for j in range, what should I do? 4, 5, I'll do 5. I'm going to say print inner, comma, I, comma, j. All right? Look at that little piece of code right there. A little freaky, yes? Let's run it. All right, do you see what happened here? This is called a nested loop. This is a loop that runs inside of another loop. So you're going to go into this loop, first one. You're going to print outer. You can see up here, outer 0. Then you're going to go to this inner loop, okay, the nested loop. And it's going to run 5 times, as you can see here. 0, 1, 2, 3, 4. So that ran 5 times. Then when it's done, it goes back up to the top. And now you run the next iteration of this loop. So you see outer 0. Now you get outer 1. And you do it again. Okay? Only this time you do it all again inside for the inner. And as you can see, boom, it does one more because we've got 3 up here. And so you have inner 2. And it runs it. Okay? This, I wanted you to see it because there's no rule against it. You could definitely do it. And the second reason I want you to see it is because later on in your programming careers and maybe even in this class, you're going to see data stored in tables. And this is the way we access data stored in tables. Okay? Think of that outer loop as a row. And think of that inner loop as a column. So, boom, first row. 1, 2, 3, 4, 5 as we go across the columns. Then when you're done, boom, increase the outer loop. Now you're in the second row. 1, 2, 3, 4, 5, 6. You go down the columns. This is the way we're going to access table or grid data. Things that are stored in what we used to call two-dimensional arrays or tables or grids. This is how we do it. Okay, so I definitely wanted you to see a nested loop. It's okay to run a loop inside of a loop. I would take a look at this because there's a very good chance something like this could show up in a quiz. Okay, wink, wink, nod, nod. Now, the next thing we're going to do is actually fun. What we've done so far is play around with definite loops. I know that loop that I ran above is going to run 300 times because I told it to. Run 300 times, give me the square, put it in a list. Okay? I know that list after that, squares, is going to run for the entirety of the list, how many ever things are in there. And if I want to know how many, I do a len on it. Okay? So those are definite loops. I know definitely what's going on. But is there a way to set up a loop where I don't know exactly what's going on and it's kind of indefinite? I want to base the ending of my loop on a condition or something that might happen. And there's a way we can do it. And I'm going to quick whip up a piece of code to show you how we do that. It is called an indefinite loop or a while loop. And I'm going to say, while char. Why is that an L? And I will just say print in loop. And then I will say now char equals input. Do you want to continue? Actually, I'll do a question mark. Question mark, colon, space, end. And just to show you that we're out of the loop, at the end of the game, I will print the end. Okay? Take a look at that real quick. Well, let's get that final parenthesis, and then we'll take a look at it. Look at that code. We're going to create a variable, and then we're going to say while char is equal to, remember equivalency, not assignment, equal to y, go into the loop. So I print in loop. Then I redefine char. See, I set it up as y here, but then I ask for it again in here. And I say input. Remember, it returns a string, but that's okay. We have a one-character string here, so that's what we want. And we say, do you want to continue? If I put a y, it goes to the top of the loop again and says while char equal to y. Well, it still is, so it does the loop again. Now, if we put anything in here that's not a y, well, then that while is not going to be true, and we're going to drop out of the loop. Watch when we run it. Do you want to continue? I sure do. I love these loops. Yes. Yes. Wonderful. Now, I didn't do any error checking, so anything I put in there is going to send me out of the loop. But I'm just going to say end for no, and it says the end, and I jump out. That's an indefinite loop, because if I run it again, first time that loop ran, what, 3 times, 4 times? Well, this time I just ran it, what, 9 times? It'll run until I give it the input it wants, okay? Now, you can also do this. You don't have to check for equality. You could also say, do you want to continue? Yes, 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 and. See, now that had the same behavior as the first loop, see? But now I'm saying as long as character is not equal to n, keep going in the loop. So frankly now, it's probably a worse situation because no matter what I put in there, it's still going to go until I enter that n, and then you're going to drop out. So this is a while loop. This is an indefinite loop. This, every time it gets to the top of the loop, is going to test for a certain condition. And when you use them is when you might change that condition inside the loop, and that tells me I want to get out of there. This is used often in a gaming context where, hey, do you want to play a game? Yes, boom, you jump in. There's a big while loop controlling the whole game. So that when you get to the end, it says, do you want to play again? You say why, it goes up to the while loop, and then you start the game process over again. Most games are just sitting in big while loops if you look at their programming behind the scenes. So that's what it does. Always, it's not a while loop unless you have a condition inside that can change that variable that's being tested. Otherwise, that's, that's always going to run. That is called an endless loop, and sometimes in computer science we get into trouble with those guys. Okay, so that is a while loop. That's what we do as far as indefinite looping is concerned. So I want you to see that. Now, if I am not mistaken, there is one last loop that you need to see, because it's actually going to come into play. It's going to come into play when you get to your second homework assignment. I put up your first one tonight, maybe a couple hours ago. Ugh, it's almost 2 o'clock. Almost 2 o'clock because I had a bird fight behind me. One more thing we're going to do is we're going to look at a sentinel loop. I am going to say the list, not my list, and I'm going to make it equal to 2, 4, 56, 78, 12, 4, 5, -7, 9, -4, 345, 2, 347, or 347. That's fine. It doesn't matter. And I'm going to make it equal. That's going to be my new list. So what am I going to do? Let's say I wanted to add these numbers up. I do a cum equals 0 for I in my list. I just said I make it to make it different, and then I type my list. For I in the list, boom, I will say cum equals a cum plus I, and then when I get down here, I'm going to print a cum. Yay, 843. Now, is that right? I'm going to tell you a dirty little secret before we get to it. I can tell if it's right now, because I'm going to use a function that's ready for me that adds up the contents of lists. It's called sum. Oh, I shouldn't be cheating like this. And then, oh, apparently I'm not going to be cheating like this. Oh, a cum. What a dope. The list. You see, it told me I needed an iterable. An iterable is something you can iterate over. That is a sequence. That is a string. That is a list. That is a file. Now you're learning about sequences. And you see it's 843. So the old-fashioned way, using an accumulator, gave me 843. The smart way, because it's already out there, just running the sum function on it, is also working. So I know I have the right number, but now here's the trick. And this is where I have to do my own accumulator. Sum's not going to help me here. What if I want to add up all the numbers from 2 until you see 300? Okay? I don't want everything past here. I want you to add up all the numbers until you see 300, and then I want you to get out of Dodge, and I want to know what that number is, okay? Now, there's a bunch of ways we can do this. One way is to just count up the spaces until we get to 300 and then do a small range up to that. That's kind of cheating. That's kind of what in computer science is what we call a fudge. We don't want to fudge. We want to write a general solution. So any list I give you with a 300 in it, it's going to add up the numbers until we see that 300. So how can we do that? I'm going to say for A in the list, and then I want to set up a condition. What is the condition I'm going to set up? I'm going to say silly, if I is not equal to 300, well then go ahead and accumulate it, because that's what I want to do. I want to add things up until I see 300. So if it's not 300, I'm good. Go ahead and do this. But I'm going to have an else. Now, for that else to be triggered, what has to be going on? Think about it. Don't answer, because this is a YouTube video and I can't hear you. All right, but what's going to happen if that else gets triggered is what? That means I is 300, right? Because look, if I is not equal to 300, we do the accumulator. But now, when I is 300, we don't want to add it to the accumulator. We want to jump out of the loop. But how can we do that? We can do that with the keyword break. See, it turned orange. Idle turned it orange. So when we have the break in there, we can now break out of the loop prematurely. So we're not going to go all the way to the end of the list. I'm explicitly telling you, hey, break out of here. I don't want you to do this. The keyword break will break out of a loop. It'll break out of an inner loop. It'll go back out to the outer. It won't break the whole construct. But as you can see, this is going to work until it sees 300, and then it's going to jump out. So using my superior math skills, 2, that's 6, that is 62, 62 and 78 is what? 62, 130, 46, 48, 52, 57, negative 7, 150, 159, 155. So do we get 155 when we run this? Or am I bad at math? I am bad at math because we got 149. I'm not going to go do it again. But whatever I did wrong, we'll figure out. So it's saying it's 149. Okay? Is that the case? There's one way we can figure out if that's the case or not. We can get rid of this, and then we can just do it the old way. All right, I'm going to put this back for you because I want you to have it, so I'm not going to erase all that. Let's see. Yep, 149. See? But I'm going to put it back for you. You know that? Because I want you to have this when I put it up later. I don't know if these numbers are right, but they don't have to be. We don't really look at them. So when I come down here, I say if I is not equal to 300, then I accum, else break. And I think that's right. Let's run it and figure it out. Yay, 149. It works. Okay, so that is a sentinel loop. That is the way we jump out of a loop. When we say break, we jump out of the loop we're in and go out to the first level or the next level. If you're in a nested loop, the break will break you out to the outer loop. Okay? I, as I always do, I'm going to save this for you. Let me go up here and get rid of this. And as is tradition, we will do a grand finale run. And you can see, oh, goodness me, it's long. And we can see everything run up and down the line. Let's see, those are our numbers. Here we go. We started here. We started here with our regular loops where we just went over lists. Then we started counting down with range. This is my 100, counting backwards by 5. Then we actually solved the real problem where we grabbed the first 300 squares and we looked at the ones greater than 50,000 and we counted them and we accumulated them and gave a running total as we did it. So we actually used our programming skills to do something semi-useful. Then we looked at nested loops, outer loops and inner loops. Okay. Oh, look at this. It's running. Do I want to continue? Yes, yes, no. Okay, so we did. So this is actually not just a indefinite loop. It's also what's called an interactive loop because we change things inside the loop until we change it to what we want, and then we jump out and it says the end. And the very last thing we looked at, sentinel loops. We looked at a loop where we're actually looking for a particular value. And when we find that value, we jump out of the loop. Or we do something else, frankly. Anything under that else would be what you do when you see the sentinel or the thing that you're looking for. In our case, the sentinel was 300, okay? It's going to be something else in a certain homework assignment you're going to get. So you're going to understand that, all right? All right. This makes me happy. This is all the code we're going to go through tonight. But this is a good point to be at because now that you have loops, you can start doing some interesting things. And you're going to see, because I did the video last night, the next video you're going to get your hands on is the Project Euler one. And the Project Euler one is fun. You are never going to want 4 practice programs ever again because Project Euler is 100 different number theory problems. They're fun. They're like puzzles, but you use programming languages to solve them. And you know about lists. You know about simple data items. You know about arithmetic. You know about looping. You realize what sequences are for. You're going to be able to attack with the skills you have now after 3 weeks some of the problems over a Project Euler. And as you'll see with the next video, and if you've read the slides already, we look at Euler problem number 6, and we go through that and actually solve that problem. So this is the turning point. This is an aha moment. This is going to show you that, hey, now we can start doing some stuff. If you came here for data science, this is the beginning of that. Okay, we're learning how to organize our data, and we're learning how to look at our data via iteration, and we're learning how to test our data with certain conditions as we look at it and regard it. in these situations where we've organized it so we can look at it and iterate over the data, okay? By the time you get this, it's going to be Sunday, obviously, because it's 2 o'clock on Saturday night, and you're probably not going to get this now. So I still have to produce it, and I still have to upload it, and I still have to do a bunch of other stuff. And hopefully the birds stop fighting so I can get that all done by maybe 3:30. And then I'll upload everything for you. Because, I know, broken record. I always say it. I want to front load the resources for you. This is the summer class, the summertime crunch. What you're getting in the first 2 or 3 days of units would usually be stretched out over the first week of the unit. I would give the slides, then maybe 3 days later you'd get the first review video. Then maybe 2 days later I'd give you the second video. And then after a week I would release the programming assignments because I want people to read first. And I want people to see the videos and try exercises and be comfortable with all this stuff before they try the assignments. Because otherwise, and I know, I was there, I get it. You guys are just going to be cutthroat and say, well, I just want to know what I have to do to get the assignment done, blah, 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 blah. And that's a crappy way to learn. You don't want to do that. I always say with this class, Python is a paint job, okay? And you need 3 coats. So what I try to do with the units is give you 3 coats. 1 coat is the primer coat. You have to read the materials, you read Zell, you look at the videos, you get all of these things in your brain and you see it running. Then, a little time later, you get the assignments. Then you have to go back and regard your resources again because you need to know what you want to do to complete your programming assignments. So then you're going back and looking at the resources again. Oh, this is how this works. Oh, that's how that works. I'll Google this, boom, 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 boom. Then, a week later, your quiz is coming up. So for a 3rd time, this is the finishing coat of the paint job. You go back and you regard the resources. And by this time, you've been through the slides 3 or 4 times. You've watched the videos. Maybe you didn't understand something, so you watched that section of the video 3 or 4 times. Now you're getting it. Now you're saying, oh, yeah, let me do that. Oh, let me do this. Now you're learning. It's the 3rd coat, and it's starting to make sense. And then you're thinking to yourself, wow, I learned a bunch of things. Every week at the beginning of my slides, I'm going to tell you how much you've learned. And when we get to the end of this class, you're going to be like, Yiminy crick, this is fantastic. Because it's going to be 2 pages long, all the stuff you've learned. Think about the stuff you've learned already. Okay? When did this class start? The last day of May? And today is the 12th? 13 days ago. It hasn't even been 2 weeks. And look what we just did here with lists and iteration and accumulators and counters. Okay? Look at a range, backwards, forwards, bliss, blah, blah. You're doing great. Take it slow. Engage with all these resources. And try in the back of your mind to keep that paint job scenario in mind. Because I do want you to see the resources in different contexts along the 10 days of the unit. I don't want you just getting the assignments and saying, this is what I need to learn to do the assignments, and now I am done. Well, that's crap. You don't learn that way. All right? You can do it if you want, but you're not going to learn anything, and you're going to go to someone and say, I'm a programmer, and they're going to say, do this, and you're going to be like, all right? You don't want that. You want to learn. You want to do it the right way. And you guys will. I'm not worried about that. I'm just telling you what will happen. If you get in a bind and you don't regard these things until 3 days before the unit is over, then you're not going to be in good shape. In these first 2 units, although it's getting a little more hairy in this one, you might be able to get away with that. Unit 3 does not suffer procrastination. Unit 3 will clobber you if you try that. You should read the resources the first day you get them and then start attacking Unit 3. You will see what I mean. All right, I don't want to drone on and on and on and on. By tomorrow, you're going to have video 1, video 2, the Project Euler video. You will have your slides. You will have your Zell book to read. And you already have assignment 1. Lastly, I also released last night the instruction sheet for your midterm project. Tomorrow, it will be exactly 1 month until it is due. That's a lot of time, but it's not a lot of time. So start thinking about how you're going to plan ahead and engage with all those resources. Because you want to do the Learn Python the hard way. Then you want to do the Code Academy. Then you got to watch those MIT lectures. You probably do 1 a week and keep notes while you're doing it, because at the end of the day, what you're going to have to do is write me 4 or 5 page paper comparing and contrasting those resources that you used to learn a little bit about Python along the way. All right? All right. Then I'm going to get out of here. I'm going to produce this video, I was producing's a pain in the rear end. I'm basically going to go through and do all the zoom ins and do some cuts and do some other things. I may even cut out some of the bird fight. I don't know how much of the bird fight you'll have seen. And then you have to render it, which takes a lot of processing, but I have an Alienware with an i7 in it, so the processing usually isn't that bad. So it takes a while, but I did the Euler video last night, and you'll see that when you watch the Euler video. So hopefully we're going to get you all your resources, we're going to get you happy, and things are going to move along, all right? As usual, any questions, any craziness, you email me. If it's a Python question, please put it in the forums. That way your classmates can see all of the answers. Lastly, do not forget to watch the Slavin TED Talk and write 5 or 6 sentences on that. Make them useful. I like TED Talks. This was fun. Blah, blah, blah. I don't need that. That's garbage. I want you to think, how does this relate to the Python? How does this relate to data science? How does this relate to what I plan on doing when I graduate and I go forward in my career? The Slavin Talk's going to be easy for you guys because it's interesting and engaging, and some of the ideas and some of the things he talks about is really, really cool. It alludes to some things like I think it was the Lewis book, Flash Boys. Some of the things in that when they built the digital networks. There's some neat stuff in there. All right? All right. Then I'm going to stop wasting your time. I know this thing ran over. So I will get out of here, and I will talk to you later. Have a good night. Bye.